Zaina, in the meantime, you just take out your solutions. When we will solve it, then you can uh, check it from there.
Yes, sir.
We have class on Sunday also. Tomorrow we have class, so please try to submit your homeworks, uh, and we will discuss everything tomorrow. If you are coming with doubt, then we will discuss.
Yes, sir.
Mm. Rishita understood the question.
Yes, sir, I will sure solve it.
Okay, okay, please do. If you are done with the first question, please try to solve the second one, and we will solve it together. Let's check what we have done. Rishita, first one solved.
Yes, sir.
Okay, okay. What was the first answer did you got? Zaina and Rishita?
So 8.
Rishita?
Yes, sir. Wait only.
Okay. Second one, Zaina?
I can check the
Acha,
second.
you are drawing. Acha. You have 30 seconds. Please do fast.
So
Hmm.
I got it as one, first one.
First option. Which option, Zaina? Hello. Zaina,
So
are you there?
option 1. So option 1.
Option one. So, with respect to B, we are clear that when we increasing the Rishita, please note down that we don't have to, you know, take so much time to solve this question. See, when we are seeing experiment 2 and 3, when we are not changing the concentration of A, but we are changing the concentration of B only. So since B is doubling, okay, the rate of reaction is becoming 4 times. So obviously, according to B, the order is 2. Okay. For the this when B is same and we are changing the concentration of 1 to 2, the rate of reaction didn't change. It was already 4, and after changing also it was 4. So what do you think with respect to A? What should be the order of the reaction?
Oh, one.
Uh, can you say that with the respect to A, means rate of reaction is not depending on the concentration of A? Is this statement is true or false?
Yes,
Ah, true or false?
yes, sir.
So when it is not affecting the rate of reaction, then the order should be 0 with respect to A, because you take any concentration of A, it doesn't matter. Are you getting my point?
Yes, sir.
Zaina, understood?
Yes, sir.
Uh, so see, if let's assume if it was 8 na, so when we are doubling the concentration of A, the rate of reaction would also doubles. Then we can say that yes, it should be the power of 1. Are you getting this?
Yes, sir.
Hmm. ठीक है, so please take lesser time to solve the questions, and it would be, just it will take within 1 minute to solve the question, right? So please try to solve more questions, and try to solve in minimum time. Then we will discuss if you will have some doubts. Okay, so let's begin our topic today. So rate of reaction, sorry, rate constant. Rate constant is represented by K, right? Rate constant, rate constant, which is represented by K here. So like we know that rate of reaction is equal to K times concentration of A, means we are assuming that the reactant side are this present and this. So for let's assume that the concentration we have here of A is 1. Okay, so and B is also 1. Okay, so then the rate of reaction will be equal to K, right? Everyone, are you getting my point?
Yes, sir.
So the rate of reaction is defined, sorry, rate constant is defined as rate constant is when defined as rate of reaction when concentration of each reactants become equal to 1, when concentration of each reactants is uh, is unity or 1. Understood?
Yes, sir.
Yes, sir.
Rate constant means actually it can come in definition also, in subjective one. So you have to write the definition also. Rate constant is also known as aka specific reaction rate. Specific reaction rate. Okay, let's write some of its characteristics. What are its characteristics? Some we have already discussed, but let's for the revision sake also. Uh, Rate constant is independent of concentration of reactant. It doesn't matter with the concentration of reactant. Uh, Means rate constant is independent of it. Then it it gives idea about speed of reaction. About the speed of reaction. Kinetics, in kinetics we are already studying speed of reaction only. So K is giving the idea about, it gives idea about speed of reaction. Okay. Greater value of K means rate of reaction is high, and vice versa. K rate constant changes with change in temperature. Change in temperature. Understood every point? K is dependent on temperature only. We will see in the nearly last lecture how K is changing with temperature, and greater the K value, greater will be the rate of reaction, and it is independent of the concentration of reactant. Got it?
Yes, sir.
Yes, sir.
Okay. Have you noted?
No, sir. One second.
Okay, please do. Done.
Yes, sir.
Yes, sir.
हाँ, so देखिए units, we are going to talk about units of rate constant. Okay. uh, in further classes we will study zero order reaction, first order reaction, second order reaction. Order, you understand, the sum of the power of the this concentrations, everyone.
Yes, sir.
Like p plus q is the order of p plus q is the order of reaction, right?
Yes, sir.
We have done a lot of questions regarding this. Okay, so where were we? So so by looking, just looking at the unit of rate constant, na, we can directly comment what is the order of reaction. Is it 0? Is it 1? Is it 2? So let's see. Rate of reaction unit is always mole per liter per second. Okay, more mole per liter. Why? The concentration term. Molarity is obviously mole per liter, and per second means rate with respect to time. So this or if it is a gas, then this at pressure per second, at atmospheric pressure per second. So this is the rate of reaction unit. We are going to relate it with that. And concentration is always what? Mole per liter, mole per liter. Okay, or ATM, gaseous case. Okay, for gas. Okay, so let's see for the first order reaction. Sorry, zero order reaction. Zero order. In zero order, and then second order, first order reaction. And then we have second order reaction. Okay, so how this is it like? We have uh, any reactant is converting into product. Okay, and the rate of reaction is in this form. Obviously there will be zero here, right? For zero order reaction, everyone.
Yes, sir.
Rishita, the
yes,
power
sir.
will be zero, right? This is important. Good. So R will be equal to K only, and rate of reaction we already know. What is the unit of rate of reaction? Mole per liter per second. So here the unit of K will be also mole per liter per second for K. If the K unit is already given as this, mole per liter per second, then it will be a zero order reaction. No need to further solve the question. Just mark the answer and move on. Let's take another example. Sorry, we have R here, obviously. Next, reactant to product, reactant to product, and we are writing its rate of reaction. So it will be like power of 1, because this is a first order reaction. The order should be 1 only. So let's write its unit. So unit is it's fixed. For rate of reaction it should be this only, and for the value of K we have to find for K what is the unit of concentration. We know this, mole per liter, right? The
Yes, sir.
concentration is this only. So this will cancel out, this whole thing will cancel out, not as, this will cancel out, and unit of K will be this. This will be the unit of K. Okay, in the like time inverse or second inverse. For the second order reaction, the R is converting into P, and experimentally it has been founded that the order of reaction is 2. So we will write here 2. Then we will try to solve this. Mole per liter per second is equal to K. What is the this concentration unit? It is mole per liter, and we have a square of it. Okay. Now it will cancel out. Okay, and this will cancel out. So what we will be getting it like mole we will also come at in the bottom side mole. Then we have mole inverse. Then we have liter, and then we have uh, this second inverse. Take second. This is cancelling only this part, right? So we will get this. Understood, everybody? The unit of K is for second order reaction is mole inverse liter. Then, or you can say if you are not clear with this, there it is actually written as liter per mole second. Okay, understood, everybody? Here it is like 1 by second for this, and here it is like mole per liter second. Tell me, are we means are you understanding the issue, maybe the problem, the theory?
Yes, sir.
Yes, sir.
Okay, please note it down. Done till here?
Yes, sir.
Mm, Order and unit of K. These two, zero order and first order, is very important. So just it, if it is 0, then unit of K will be mole liter second inverse. If it is 1, then it is second inverse. If it is 2, then it is mole inverse liter second inverse. That is it. Directly use this, means this trick, to comment on the order of reaction. General formula is this: mole per liter 1 minus n second inverse, और यहाँ पे n is the order of reaction. If you are done, please solve this question after doing this, after copying the above thing. Done copying?
Yes, sir.
Rishita,
Yes, sir.
done?
Yes, sir.
Now, have you solved this question? You, both of you?
Writing, sir.
No, you don't have to write the question. Just solve this question here only. Means write the next question which I will say. Is what is the answer?
Zero order.
Rishita, can you see the unit of rate of reaction is for when the rate of reaction is same for rest as the rate constant. So in rate constant, we have four options: zero, first, second. So in zero, first, second, at least we can check. So for zero order reaction, we have mole per liter per second. This is the rate of reaction only. Obviously, then zero order will be the correct answer. Okay. Please
Yes.
solve this question, and you can copy this question also in your notebook. You have 1 minute to solve this question. Done.
Yes, sir.
Yes, sir.
What is the answer you are getting?
Um,
First is
second order
second
reaction
order
One by
and
one.
second is first order.
and
Rishita,
first order.
first you tell.
First one is second order reaction.
And second one, Zaina.
Second is first order.
Good. So this is see just by seeing the unit of k, obviously not the value of k. That with the unit of k, you can directly comment it that what is the order of reaction, right? Understood?
Yes, sir.
Ha. Now we will see this another topic. Uh, this comes under mechanism of reaction. Mechanism of reaction. Okay. Actually, in real life, uh, there are two types of reactions which to takes place and which we have to study also. Elementary reaction, elementary reaction, and complex reaction. Complex reaction. Okay. if if the reaction if the reaction is taking in single step, reaction taking place in a single step, so this will be a elementary reaction. And if reaction is reaction taking place in multiple steps, place in multiple steps, then this is a complex reaction. Let's see with example so that it will be more clear to you. Example, 2a plus b is giving c plus d. Okay, any example? No problem. So this is an example of elementary reaction. Okay, so this is actually happening in the real world also. That two molecules of A is coming with and colliding with one molecule of B, and because of some proper collision, we are getting the reactions takes place, and C and D forms. So we can write here is the rate of reaction is equal to K times. Okay, it is dependent on A and B, and here since this is elementary step, this is a elementary reaction, this is a very rare uh, elementary reaction. Here only we can write the stoichiometric coefficients of the reactants. So a stoichiometric coefficient of A is 2 here and B is 1 here. So this is the rate of reaction, and the order we can say is equal to 3. Okay, but in complex reaction, what happens is this is a complex. So let's write its example. 3a plus 2b is giving C, for example, and this is a complex. This is known. Okay, this is a complex reaction. Okay. Acha, have you remembered that I have told you that rate of reaction which we are writing here is can be found out experimentally only. We cannot directly write this, right? We can find this by experiment only. Do you remember, everyone?
Yes, sir.
Huh. So, but if the question says that this is a elementary reaction, then your means you don't have to worry. You just see the stoichiometric coefficient present here, and you can put it here. Okay, with the power of the reactant. Got it, Rishta? Got the special case of elementary reaction that we can directly put the stoichiometric coefficient here. Okay.
Yes, sir.
Huh. Let's see this complex reaction. The most of the reactions are complex only. So it's mechanism. So when 3A is reacting with 2B, C is forming. But this is not actually happening. Actually, what is happening is two molecule of A is reacting with B and giving some P compound. Then what happens? P reacts with one of the A molecule and gives Q compound. Then Q which formed will react with B and give some C compound. Okay, and this is the in 3 steps. This reaction took place, and finally, when we see the reactant, the product here, so the reactant, let's sum up this equation. So in the product side we have P here, and reactant side this has completely got exhausted. Similar is the case with Q also. Okay, and none of means no more. Now we can add it. 2A plus A, 3A plus 2B is giving C. Okay, because some of the intermediates are cancelled out within the reaction only. So this is the final reaction. But actually what happened? This happened in 3 steps, which no one has observed. This is the actual steps. Okay, got it? How elementary and complex reactions are different, because this is taking place in multiple steps, and this took place in 1 step only. Okay,
Yes,
understood?
sir.
Huh.
Yes, sir.
And we means one of the step is rate determining step. One of the step is slow step. This is important to know. One of the step is slow step, which is known as RDS. RDS, rate determining step. Okay, this is the actual main step, which is known as rate determining step. What is the special thing about it? That this reaction is the slowest step in the complex reaction. Okay, so by this we can write the rate of reaction as according to the slowest step only. So the rate of reaction will be K times, we have A here, which is what, 2, and we have B here, which can be written as 1 here. Okay,
Yes, sir.
understood? This can be
Yes, sir.
written just by seeing the slowest step in the complex reaction. Got it?
Yes, sir.
Hmm. So, please note it down. Since the first step is slow step, that is why it is known as rate determining step. So the rate of reaction is completely dependent on first step only. That is why only the order is coming from that reaction only. So we have written uh, uh, A ki power 2 and B ki power 1. When you people are having exam in your schools, final exam? Hmm?
So final exams would start like from mid-February and go on till March, whole
Before
of
that,
March.
any exam?
Yes,
We
sir.
have pre-board.
Pre-boards, when you have pre-boards?
We don't know, sir. November
Uh,
and January.
Maybe November or
yes.
January. December, you have holidays.
No, sir, in December as well, we'll have one pre-board. We will also probably have our practicals.
You have practice. No, pre-boards is one time only, na? You don't have two pre-boards.
No, sir. We
We
have
have
Two
we
pre-boards.
have
Oh, okay. The first pre-board could be on in October.
no, sir. November.
no,
I have holidays on December.
Okay, November, mid-November, mid-November, na?
yes, sir.
Most probably, na, after this, we have organic part left and redox reaction, right? Rest of your chapters are done, I think. Your organic is done.
Catalysts, aldehydes and ketones and
Acha, your
esters,
organic
all
is
of
done.
that. Yes, sir.
Acha, I'm confused. Okay, which
We have
portion?
biomolecules.
Biomolecules is left.
Yes, sir. We didn't do that.
Okay, and
So we have to check once to be sure.
okay, I think I can see. Acha, your electrochemistry is also done. Okay, okay, ठीक है. You have left this carboxylic acid is done.
Yes, sir.
Yes, sir.
Uh, Most of the portion is done. Okay, okay. Let's. Acha, you have copied. Done.
Yes, sir.
Copying. Huh. So understood.
Yes, sir.
Huh. So please solve this question. Solve this question. So can you people see this is a complex reaction because it has already mentioned that one step is slow, one step is fast. Okay, so this is taking place in two steps. So that is why this is a complex reaction. Okay,
Yes, sir.
and this is the slow step. This is the RDS. This is the rate determining step. According to this, only we can write the order of reaction. Now, please solve this question. Done.
No, sir.
Done the first part? Which part
No.
you have done? First, second, third.
Sir, can you explain how to write this question, the first and second part?
Uh, Rishita, I will explain. Rishita,
Yes, sir.
so it seems you people are stuck. So let's solve this question. So question says that this is the reaction. However, it already told that this is a complex reaction because it has broken the exact reaction into two steps. Okay. Hmm? Then it is saying that write the law rate law for the reaction. So obviously the answer will be not this, means you can say direct R. R will not be equal to like this H2O2. Why? Because this is not a elementary reaction, not a elementary reaction. How we can say that this is not elementary reaction? Because the students, the teacher has given the question like one reaction is slow, one reaction is fast, and that is how this reaction take place, right? Have you understood that how this is not a elementary reaction,
Yes, sir.
Rishita?
Yes, sir.
Huh. So which we will take this one or this one to find the rate law of reaction, the first one or second one? Just tell me.
First part.
First one. Rishta, are you getting this?
Yes, sir.
So we will take the first one because this is the slow step. This is all the rate determining step on which the rate of reaction depends. So rate of reaction will depend on this. So what we will write here? This H2O2 and I minus. This is ion with the power of 1 only. Okay, understood? Please let me
Yes.
know which part you have
Yes.
understood. I can repeat or I can explain if you haven't got this. Zana?
Yes, sir. Got it, sir.
Uh, Now what we are seeing, overall order of reaction. Zana, you tell me what should be the order of reaction? What is the order of reaction? Hmm? I thought you have said two,
Uh, no, sir.
but it is two because the coefficient, the power here is one and one. So one plus one will be two.
So from the main reaction,
No, why? The main reaction is this only. Everything will depend on this reaction now. Why? Because this is the slowest step. This is the elementary reaction of the complex reaction. Are you getting my point?
okay, so both of them are one, the power of concentration.
Uh,
So the order of reaction we get two.
1 plus 1 is equal to 2 because the order of reaction is sum of the power of the concentration of the reactant
Yes, sir.
in the order of reaction. Rishita, did you got this?
Yes, sir.
Rishita, please tell me the third answer. Answer for third one.
So the first one.
First one. That's correct. Understood, Zana?
Yes, sir.
Uh, so you have understood now. Let's move on to a small topic related to this only, molecularity of a reaction. Molecularity of reaction. As I have told you earlier, that in this one, that in elementary reactions, what happens? Two atoms or molecules, two compounds of A is colliding with the one molecule of B, and C and D are forming. So this is the molecularity of reaction. What is the definition? Let's see. It is defined as number of molecules which must collide simultaneously. Simultaneously in an elementary reaction. Like in this reaction, 2A plus 3B, if 1A and 1B is colliding, the things will not work out. Two molecules of A should collide with one molecule of B simultaneously, then the reaction will take place. So this is the definition of molecularity of reaction. Okay, that the reactants where the number of molecules should collide should be colliding at a single point of time. Okay, so that is in the elementary reaction. Okay, the second point you must know that molecularity of reaction is only applicable for it can come in assertion reason, applicable for elementary reaction. And have no significance for complex reaction. Okay, now one more point. Molecularity greater than 3 is rarely observed. Means more than 3 molecules colliding simultaneously is rarely observed, right? Means possibility of collision of 2 is obviously more than 3, and 4 molecules colliding simultaneously is very low. That is why the statement is molecularity greater than 3 is rarely observed. Are you getting this, Zana and Rishita?
Yes, sir.
Yes, sir.
Just try to imagine that one molecule of two molecule of A is coming and colliding with one molecule of B simultaneously. Okay, so and this happens, and other molecules form P and Q. Okay, oh sorry, C and D. That is it. And if somebody is saying that 4 molecules are coming and colliding, so this is rarely possible. To bring means more people on a common table, that is difficult now. So this is example you can understand by this. Some more points to be understood. The major points are there only. It is a theoretical concept. Okay. It is in whole number. only can't be fractional or negative or zero. Means zero molecules colliding is, like sounding very vague. It doesn't change with change in temperature, pressure, etc. Please note it down. Have you noted down this question?
Yes, sir.
Yes, sir.
Good. I think when I tell you to solve the question, you people start writing the question. This is not the correct way. I will give you time to solve the question. Just solve it in rough and give me the answer next time. Please note down this. Rishita, you were present in last two classes. Just asking. Zaina,
Yes, sir.
okay. Rishita,
Yes, sir.
so more people were are on Saturday or Sunday in the class because next classes are very important. We are going to understand the concept of zero order reaction, first order reaction.
Sir, I think there's one more person in the class.
No, I can see two people only.
No, sir.
No,
Generally,
not only me.
Generally,
In
I think we
general,
have
in our
four
batch.
people in the class. I don't remember some names. Done writing,
Yes, sir.
Rishita.
yes, sir.
Hmm. So see, examiner can confuse you with the molecularity thing or order thing, है ना? Complex, elemental. So let's see. We have to comment on the order and the molecularity for complex reaction. Okay. So as we have, written here in some point that for complex reaction, it has no, significance. It has no significance. It has no significance. It has no, yeah, no. I left no. It has no significance for complex reaction. Complex reaction. And you people already solved what? For the order thing, it can be determined by how? By the slowest step, right? Determined by the iodine one, which you have solved earlier. You checked out which is the slowest step and just you have found the order of the reaction. Do you remember this one? Like this one was complex reaction, but still you can find out order of reaction. How? If you get the reaction which is slow, which is the RDS, which is the rate determining step. Okay, it can be determined by the slowest step. Slowest step will be one only. Don't worry. Slowest step in complex reaction. Understood? You understood?
Yes, sir.
Everyone?
Yes, sir.
Please note it down. Now I will request you to please solve the questions. Okay. Otherwise, nothing will work out. Nearly 40% of the chapter is over. This chapter has lots of formulas. Also, you have to understand the concepts. Done.
Yes, sir.
Now, just start this zero order reaction. Sorry, reorder reaction. Zero order reactions. Okay. So, Rishta done.
Yes, sir.
Rishita. So let's see what is a zero order reaction. Example, like A is converting into B product, and what we know that rate of reaction, we can say that R is equal to K times this thing. Can we? Are we good?
Yes, sir.
Rishita, this is okay. We have to put zero here because this was a zero order reaction. Okay. Rishita,
Yes, sir.
are you sleepy? Feeling sleepy?
No, sir, I couldn't click on the mic because my start
Okay,
button
okay,
was.
okay. So this is a way of writing rate of reaction. There is another way also, which you have learned before me, that rate of reaction can be written as for the reactant size like this. The change in the concentration with respect to time with a minus sign because this the reactant is will decrease as the reaction forwards. Okay, so understood. I hope
Yes,
you
sir.
people so we will equate both of these rate of reaction, then we will get this, and this A ki concentration power 0 will be 1, so we will get this. Okay, now what we will do, please look on onto the board and you know then you can copy it later, don't worry. I will give you time before 8 we will end the session today. So dt will be coming here. Now we are integrating both side. Okay, so and we will integrate like this and we will get like this. Understood? K was constant, that is why it is out of the integration. Okay,
Yes, sir.
are you are getting it or not?
Yes,
Yes,
sir.
sir.
Because na sometime maths come and people gets confused. That is why I was asking. Like I've written it like this. Okay, so I think you people will be okay with this. Now we can write this also in the next step. Now see. After this, we will execute. So it will become this. Then KT plus C. Okay, because this has been integrated. Now at t is equal to 0, at time 0, the initial concentration of A was A naught. Okay, at time 0 means the reaction was not yet started. So that is the time. That was the time at t is equal to 0. The reaction will start. So we will put A as from this equation. From this equation, we will put A as A naught. Okay, and what we put at t we will put here as 0, obviously. So after solving, what we get, A naught is equal to C. Okay, A naught is the initial concentration of reactant. Are you getting this?
Yes, sir.
Yes,
Now
sir.
the reaction which we, this is the main equation from the from one from equation 1, what we see as this means we want to get the value of C. That is why we have to gone through this step, and we have put C as A naught. Okay, we can write this as, proper way to write as A naught minus KT. A naught was the initial concentration of, let me write it for you so that you always remember, initial concentration. Initial concentration. What is K? You already know, rate constant. Okay,
Yes, sir.
T is time from when the reaction started. A will be the remaining concentration of A. Are you getting this, everyone?
Yes, sir.
This is, very important formula. We will go again and again visit this formula. So please note it down. Before noting down, uh, अच्छा हाँ पहले नोट कर लो. Understood the steps, everyone?
Yes, sir.
Rishita,
Yes,
if
sir.
you want, अच्छा ठीक, करो. Done? Yes or no?
Yes, sir.
Yes, sir.
Okay. So I will give you some basic questions. You have to just apply the formula here. This will be the remaining concentration of A. This is the final initial concentration of A. K is rate constant and T is the time. And obviously we have four variables here. So three will be given in your question, and the fourth one you have to find out. Okay. So can you do this?
Yes, sir.
The three things will be given in your question. You have to find out the fourth one. So, so I think we are done for the day. Please, solve the previous questions. The last which I have given you, we have already solved two questions. I think we have left with 7 or 8. So please try to solve them, and I will give you some basic questions today also. So we will meet tomorrow. Okay. So thank you. Assalamu
Thank you, sir. Bye.
alaikum.